Good morning. Happy Tuesday, everybody. Today is like a Friday because tomorrow we have a holiday, right? We're going to honor the veterans, right? Remember, veterans are anybody who served in the military during time of war. Okay, we're going to honor them because they fought for us and for our country. So no school tomorrow, no asynchronous either, right? Yeah, you can, if you want, work on some con or anything that's old that you want to do, but no new assignments coming your way. So make sure you enjoy the day and make sure you spend a little bit of time thinking about those who fought for our country, all right? Okay, warm up for today. We got 4 diamonds, we have 4 prime factorizations, and we have one big word problem that is not that hard. Okay, it looks hard and it would be hard to do in one step, almost impossible. But remember, you can lift a ton of bricks and you can carry a ton of bricks from the front yard to the backyard. You just can't do it in one trip. So don't try to do this in one step. Break it into little parts. And pretty soon, after doing a bunch of easy little parts, you'll find out that you solved a pretty complex problem. Okay? All right, copy it down. After you press pause, go do it, and then come back and see how you did. And here we are, ready to go through some answers. First time is 48 and 14. That means I have 2 numbers that have a product of 48. So we would call those numbers that make a product factors, right? And then we have 2 numbers that have a sum of 14 and 2 numbers that when you add together, this one's easy to remember, you get a sum are called add-ins. Okay, so again, why would you need to know that? Because you want to be bilingual. You want to learn those words, right? Those words, so they don't freak you out and you don't spend a whole lot of time worrying about those words when you hear them. You can just go on and know what those words means and worry about the math, right, when you hear them, right? Because you're going to hear them in a math class and they're going to be talking about things, and don't get tripped up on them, right? They're easy things to get past. So use them every once in a while, and then when you use them, you own them, right? Instead of having them own you. 48 and 14, what numbers work there? 6 and 8, 6 times 8. And remember, 6 times 8, same as 8 times 6. Part of a fact family, part of the, but wait, there's more, but also called commutative property. Same thing frontwards as backwards. Multiplying and addition are commutative, division and subtraction are not. On to the next one, 63 and 17. What do you got there? Uh-oh, I made a mistake. 63 and 16 on that one. 9 times 7. So, yeah, sorry about that. If you got that and got stuck, it's because you were smarter than me. Okay, 9 times 7 is 63. 9 plus 7 is 16, not 17. And how about 55 hundredths and 1 and 6/10? What do we have there? It's a tough one, but 5 times 11 is 55. And if you have 1 and 1/10 and 5/10, you pretend there's no decimal when you multiply, so that is 5 times 11. And then you figure out how many places you had to move decimals in your problem so you could pretend that. And in this case, I had to move this one over 1 and this one over 1. So that's a total of 2. I go back 2 places in my answer. So that works. Remember, when you add decimals or subtract decimals or compare them, you want to stack them and line them up. Whoops, that's not 1.5, that's 1.1. And then once you line up the decimal, you just add, right? So 1.6 works there. Okay, 4 hundredths and 4 tenths, 2 tenths and 2 tenths, 2 tenths, 2 tenths. I think that's going to be very similar to the answer to a pizzazz joke you're going to do later this week, if I remember right. So you add those, line up the decimal, you do get 4 tenths. When you multiply, you go 2 times 2 is 4, and realize I had to move that over 1 to pretend there was no decimal, that over 1, so I got to go back 2 spots. When I go back 2 spots, got to put an egg in there, right? 4 hundredths. All right, hopefully you got those 4. And again, sorry about that one. 35. What numbers multiplied together equal 35? 7 times 5, right? And 7 is prime, so I'm going to circle it. 5 is prime, I'm going to circle it. And then the prime factorization is not 7 times 5. I got to put it in order. You want those, it equals 7 times 5, but they like the prime factorization in order from least to greatest. And that helps you when you have bigger numbers. Here's an example. Okay, you could do 3 times 12, 4 times 9. You could do 6 times 6, right? What if we did 6 times 6? Make it all nice and balanced, right? And you're going to do 3 times 2 and 3 times 2. And you circle all 4 of these because those are all prime, 2s and 3s. Now, put those in order. 2 times 2 times 3 times 3. And if you want to write those using exponents, now what you've done is you've given me the prime factorization of 36 in exponential form is 2 squared times 3 squared. Pass the salt, right? Again, have fun with stuff like that. When mom says, what'd you learn today? Instead of saying, nothing, say, I learned that the prime factorization of 36 in exponential form is 2 squared plus times 3 squared. Say it all nonchalant, like nonchalant means like it's no biggie, right? All right, 37, 2 doesn't go into it because it's not even. 3 doesn't go into it. Why? Because 3 plus 7 is 10, and 3 won't fit into 10. So 3 won't fit into 37 or 73. I don't have to check 4. 2 is the only even number I check. Why? Because 2 goes into every other even number. So if 4 goes into a number, 2 will go into it twice as many times. If 6 goes into a number, 2 will go into it 3 times that many. Okay, so what am I doing next? I'm checking 7, and 7 does not go into 37 because 7 times 5 is 35, so I'd have 2 left over. How many numbers do I have to keep checking? Well, I check until I check a number that times itself is bigger than that. 7 times 7 is 49. I'm done. I know that's prime. Instead of a factor tree, you call that a factor seed, right? Now, 38 is even, so I know 2 goes into it. How many times? 19, and both of these are prime, so the prime factorization of 38 is, boom, you're done. Not too bad, right? All right, Dad found a ping pong table, woohoo, at a garage sale. No paddles or balls, though. Oh, man. So he went to Walmart and found 3 packs of ping pong balls for $6.76 each. That is an important word, right? And 2 paddles for $11.43 each. Important word, okay? If you can write on your word problem, I definitely recommend doing it. You read the whole thing first, then you go back and circle and underline important things, okay? Tax was $3.62. He paid with a $50 bill. What was his change? Okay, so what are we trying to do? We need to figure out the total of everything he bought, right? Add it all up, and then subtract that from that $50. So 3 packs for $6.76 each. What do I got to do there? I got to add $6.76 3 times, or did I just say 3 times? Right? Why do we say times? Okay. Now, when I do these, I should get the same answer. Okay? So I could do it either way. 6 plus 6 plus 6 is 18. 7 plus 7 is 14. Plus 7 more is 21. Plus 1 is 22. The decimal comes straight down. And I already said 6 plus 6 plus 6 is 18. Plus 2 more is 20. Now let's try this one. I multiply. Remember, I'm going to pretend there's no decimal. 3 times 6 is 18. Carry the 1. 3 times 7 is 21. Plus 1 is 22. Carry the 2. 3 times 6 is 18. Plus 2 is 20. Now, where am I going to put the decimal? Well, in order to pretend there was no decimal, I had to move this over twice. Nothing here, so I have to move over a total twice the other way. Same answer. Okay? So, all the ping pong balls came to $20.28. How about the paddles? Now I have 2 for $11.43. Again, you can add those if you want, or multiply by 2, but don't multiply 1143 times 1143, right? 6, 8, 2, 2. All right, so I got this and I got this. All right. The ping pong balls, the ping pong paddles, and what else? Oh, don't forget the tax, unless you're buying food, right? That has not been prepared, right? If you go to Taco Bell, you got to pay tax. If you go buy the ingredients at Rayleigh's for the tortillas and food, you don't have to pay tax on the food. All right, so 14 plus 2 is 16, carry the 1. 10 plus 1 is 11, plus 6 is 17, carry the 1. The decimal comes straight down. I got 6 and 4. I got $46.76. That 50 is the same as 50.00. So I'm going to subtract here. I got to change in that $50 bill, right, for 4 10s and 9 1s. And now I have 10 dimes, and I'm going to change in one of those dimes. You get 10 pennies. Now, 10 pennies minus 6 pennies is 4. 9 dimes minus 7 dimes is 2. The decimal comes straight down. 9 1s minus 6 1s is 3 1s, and 4 10s minus 4 10s is 0. $3.24 change. How'd you do? All right. Make sure you guys finish all your homework. Ask your teachers questions. Remember, you want to ask your teachers questions before the test. Go look at today's comic book, the comic strip in the Press Democrat, and don't be a peppermint patty, okay? All right. See you guys Thursday. Have a good Veterans Day.